Okay, this is the AQA Further Maths GCSE, the level 2, paper 2 calculator paper from the June 2024 series. Right, question number 1, fairly straightforward, that's 4 points, draw a line through them. Question 2, subtract 2 from both sides, divide both sides by 5. And then square root. Now when we're square rooting, we just have to remember about the negative square root. That's going to sandwich n in, so n's going to be between negative 2.7 and a bit and 2.7 and a bit. And the integers between those values are -2, -1, 0, 1 and 2. For question 3, we want to know when the rate of change is 23, so I'll differentiate. Fairly straightforward. Set the gradient to 23, x is 2, substitute all that in, and we get an equation just in terms of k, and we can solve the equation as you can see there. I'll put the k's onto the left, the non-k's onto the right, divide by 12, 9/12 is simplifies to 3/4 or 0.75. For question 4, well, we know that the two nth terms of the sequences A and B add to make C. I can see that B, 14, 22, 30, 38, that's the 8 times table, or 6 more than it, so A10 plus 6. To work out A, we can subtract B from C, so 42 minus 3n, subtract our B, our A10 plus 6, is 36 minus 11n, so that's going to be our nth term for A. Substituting 20 into that, we get negative 184 for the 20th term. For 5a, carrying out a couple of calculations. The first calculation, c times -2 plus 1 times 7 will be equal to -5. From that, we can solve the equation to find that c is 6, and then doing 5d times -2 plus 3 times 7 is going to be 0. Add 10d to both sides, divide both sides by 10, you'll get d to be 2.1. So c is 6, d is 2.1. For 5b, nothing changes, m's the identity matrix, 1, 0, 0, 1. For 6, the lowest value is going to occur when x is 0, because you're squaring 0 to get 0 in that one. So you're not going to go below that. If you chose -1, you're going to get a number larger than 2, so your range won't be correct. The most extreme is going to be when x is 4, plug 4 in, you get 50 out, so f of x is going to be between 2 and 50. That's the range on this restricted domain. Substituting x equals 0 in, we get -5 out, and the minimum point is going to be 3, 4. For question 8, asks us to work out d2y by dx squared. So we're going to differentiate twice. The first thing we're going to do is turn our equation into something that's nice to differentiate. Rewriting 3 over 4x to the 4 is 3/4 x to the -4, and then multiply by the power, subtract 1 from the power, so half x squared differentiates to x, and the second part minus 3x to the -5. Then we differentiate it again, so x differentiates to 1, and then multiply by the -5 gives us plus 15, subtract 1 from -5 gives us -6, so 1 plus 15x to the -6. Question number 9. I've done a lot of listing here in the sense of I've listed the digits. It could be the first digit, so we could have 7, 8 or 9 as the first digit. For the second digit, we could have any of the digits 7 or below, so 7, 6, 5, 4, 3, 2, 1 or 0. The third digit could be any digit, it really doesn't matter, so that could be 9, 8, 7, 6, 5, 4, 3, 2, 1 or 0. It's not necessary to list them all, you could have been more efficient than me here. Finally, the fourth digit has to be either a 0 or 5. And so to work out the total number of ways, well, there's 3 in the first, 8 in the second, 10 in the third, 2 in the fourth. 2, which is 480. So the answer is 480. Question 10, well, the tangent at 1b, that's a tangent at a maximum point, so that's going to be horizontal, so yes, that is parallel to the x-axis. There is only going to be two values when y equals 0, so that's false, and between 0 and 1 we can see the functions going upwards, so that is true. For question 11, I'm going to use the sine rule to find AC. So AC over sine 59 will be equal to 18 over sine 66. Multiply both sides by sine 59, we can calculate AC, so 18 sine 59 over sine 66. Plug that into the calculator, it comes out as 16.9 and a bit. Then to find the area of ACD, half AB sine C, we've got our two lengths now, so it's going to be half times 15 times 16.9 and a bit, times by sine of the angle between them, sine 70. Use the answer function on your calculator to avoid rounding partway through the question, but it comes out as 119 if you've done that correctly. Right, question number 12. I'm going to substitute y for 4 minus x into the equation of the circle. So where it was y plus 3, it's now 4 minus x plus 3. Nothing else has changed. Then expanding out x minus 2 all squared, x squared minus 4x plus 4. Tidy up the second bracket, 7 minus x now, and that's still equal to 16. I'm now going to expand out the 7 minus x, leaving the x squared minus 4x plus 4 alone. So that's going to be plus 49 minus 14x plus x squared. Still equal to 16. And then move everything onto the left-hand side and collect like terms. 2x squared minus 18x plus 37 is equal to 0, which is what the question wanted. For B, we want to solve the equation with it being equal to 0. So here I've substituted A for 2, B for negative 18, and C for 37 into the quadratic equations formula, minus B plus or minus squared B squared minus 4AC all over 2A. There you go. And that gives me 2x values 9 plus or minus the square root of 7 over 2. Those are, in the decimal versions, 5.82 or 3.81. Both of those are positive, which the question wants it to be. And so we can use the linear equation to work out the corresponding y values. So 4 minus the x values will give us 2 y values. The one for 5.82 is negative 1.82. And when x is 3.18, we get y to be 0.82. There's only one of those where they're both positive. That's the one on the right. So that's the one I'm going to choose for the answer, 3.18 and 0.82. Question 13, expanding. I've actually multiplied together the first and the third brackets together. I thought there'd be fewer negatives. Dealing with the 4 minus x is just another thing to think about when doing the calculations. However, if you've multiplied the first two together, or indeed the second and third together as your first step, that will be absolutely fine, as long as you do so carefully, and when you collect your like terms at the end, you'll end up with the same answer. Multiplying by 4 minus x, multiply each bit by 4, then multiply each bit by minus x, and then group everything together. I like to write these in descending powers of x, so minus 6x cubed plus 11x squared plus 57x minus 20. Question 14, so the y-coordinate of p, let's work that out by putting negative 2 into the graph y equals 3 to the minus x. So it's 3 to the power of minus 2, or 3 to the power of negative 2, or if you prefer just 3 squared, which is 9. Then equating that in the second equation, where q is, we get that 9 would be equal to the 1152 times x to the times a half to the power of x. Divide both sides by 1152, it simplifies to 1 over 128. You could start expanding this out now, 1 to the power of x on the right over 2 to the power of x, and then move everything around. You get 2 to the x is 128, but you can just spot that a half to the power of 7 is 1 over 128, 1 to 8 is a power of 2, so x is 7. Question 15, factorise the numerator. You can, if you're sneaky, work out that one of the brackets in the factorised version of the denominator is going to cancel, and it's not going to be x plus 6. So that's a cheeky way of making it a bit easier for you if you want to, or you can find the solutions to it being equal to 0 and reverse engineer it. Either way, x plus 6 over 6x plus 5 if you've done it correctly. Playing with the surds, the square root of x cubed is x to the power of 3 over 2. And root x on the denominator is x to the power of a half. I could have cancelled here, x to the 3 over 2 over x to the half might have been slightly easier. Anyway, I went with expanding the numerator out first, and then subtracting a half from each of the powers, giving me x to the power of 5 over 2 plus x to the power of 4. Question 16. Question 17a, so we're looking for that angle there that I've called theta. The total surface area of the cone will be the curved surface area plus the area of the circle underneath, so 7 pi l plus pi times 7 squared is going to be equal to the 224 pi. First thing I do is cancel pi from everything, so leaving me with 7l, 7 squared is 49, and then pi's gone from the right hand side, subtract 49 from both sides, divide both sides by 7. We can calculate L to be 25. That's actually sufficient for us to work out this angle. Now we don't need to find out what H is, because we can do cos of theta being the adjacent over the hypotenuse. So theta is inverse cos of 7/25, 73.7 degrees. Question 17b. If you can visualize the shape, you can work out that the angle that I've marked there, BNC, is the angle that it's describing. That's 36. And so a bit of straightforward trig on that triangle. Triangle BNC, tan of 36 will be 25 over c to n. And so c to n will be 25 divided by tan of 36, which is 34.4. Question 18, rearranging to make k the subject. First thing I can do is multiply by the denominator. So 5m squared minus 3k cubed m. Multiply by the denominator and expand in one go, that's fine. Then I've decided to bring the k's onto the right hand side of the equation. It keeps everything positive, so it makes it look a little bit tidier. If you moved everything onto the left, that's absolutely fine. You cancelled the negatives later on, or maybe you just left them in there, that's also fine. It doesn't want a simplified expression, it just wants k to be the subject. Factorising out the k cubed from the right hand side and then dividing both sides by 2 plus 3m, we get an expression for k cubed. And so the last step is to cube root both sides. So k is equal to the cubed root of 5m squared plus 7 all over 2 plus 3m. Question 19, we've got a binomial expansion here. Pascal's triangle to help us. You don't have to do that. You can use the choose function on your calculator, or maybe you just know the fifth row. For the x squared expression, we'll take 10 from Pascal's triangle times by 3 cubed times by the ax squared. That will give me 270 a squared x squared. That's the coefficient of x squared. It's 270 a squared. And then for the coefficient of x to the 4, that's going to be the fourth, or the fifth, I suppose, term in the expansion. So 5 lots of 3 to the power of 1 times by ax to the power of 4. That comes out as 15a to the 4 x to the 4. And we know that 8 lots of the coefficient of x squared is the coefficient of x to the power of 4. So 8 lots of 270a squared is going to be equal to 15a to the 4. Divide both sides by 15. Divide both sides by a squared. That's fine because we know a is a non-zero constant. And square root it, a must be plus or minus 12. Question 20. I'm just going to draw a little radius in there, connecting the centre up with our point. The gradient of that line, the gradient of the radius, if you like, is going to be 9 minus 4 over 5 minus 3. That comes out as 5 over 2. AB is perpendicular because we have a tangent and a radius, so the gradient of AB is going to be the negative reciprocal of 5 over 2, which is negative 2/5. And so the equation of the line passing through A and B is going to be, well, y minus y1 equals mx minus x, and y minus 9 equals negative 2/5 of x minus 5. We could tidy that up if we wanted to. I'm not going to bother. I'm just going to substitute x to be 0 in. To work out the y coordinate of A. When you substitute x equals 0 and you quickly work out that y must be 11, and substituting y equals 0 in allows us to find the x coordinate of B, and therefore that x coordinate comes out as 27.5, and those are the two perpendicular side lengths of the triangle we're trying to find. So a half times base times perpendicular height, a half times 11 times 27.5 gives me the area 151.25 square units. Okay, question 21. The first thing I'm going to do is find f inverse of x. So I swap the x's and y's around and make y the subject. You don't have to switch the x and y's around if you don't want to, but we end up with y equals 2 minus 3x. So f inverse of x is going to be 2 subtract 3x. Okay, g of f of x, I'm going to embed f of x into g of x, which means rewriting g of x with 2 minus x over 3 wherever there's an x before. So it'd be 18 lots of 2 minus x over 3 all squared, plus 15 lots of 2 minus x over 3. I'm going to square the 2 minus x over 3. We can square the numerator and the denominator all one at a time. Squaring 2 minus x, double bracket expansion, 4 minus 4x plus x squared. Squaring 3 gives us 9. Plus the 10 minus 5x, which simplifies for the right-hand part. 18 lots of that fraction, while the 18 and the 9 cancel to give me 2 lots of it, so I can just double the numerator, 8 minus 8x plus 2x squared, then plus the 10 minus the 5x, and lastly collect all that together, 2x squared minus 13x plus 18. Then the question wants us to write f inverse of x plus g of f of x together as a quadratic. So taking the two parts that we've calculated, we get 2 minus 3x from the f inverse of x. Add the 2x squared minus 13x plus 18 from the g of f of x, and group those together, 2x squared minus 16x plus 20. We can see that a is 2, b is negative 16, and c is 20. Question 22. First step here, I'm going to use the alternate segment theorem. ACB is going to be equal to y, because ABP is y, and ACB will be equal to ABP. They're in alternate segments. That allows us to construct an expression for the angle CAB, because ACB is an isosceles triangle, so its two base angles are the same. I can take that y, subtract it from 180 and halve it to work out CAB. So 180 minus y over 2, or if you prefer, 90 minus y over 2. Just going to mark those on the diagram there. So there's the y from the alternate segment theorem, and there's the 90 minus y over 2. Then we can work out angle PAB, because PAC is a straight line, so 180 subtract our angle CAB, 180 subtract 90 minus y over 2, which simplifies to 90 plus y over 2. Then I can mark that on the diagram just there, 90 plus y over 2. We now have expressions for the three angles in the triangle PAB. So the sum of those three angles will be 180. We've got the x on the left, we've got a 90 plus y over 2, and we've got a y. That's going to sum to 180 degrees. Y over 2 plus y will be 3 over 2 lots of y, 1.5y. Subtract 90 from both sides, subtract 3 over 2y from both sides. We're going to get x is equal to 90 minus 3 over 2y as required. Well done if you managed to work that one out. All right, bye.